Good morning, class, and welcome to this lesson on Magnetism 9 induced current slash EMF. Today we will be able to describe the three situations that will induce a current in a wire. Okay, so um, what we learned before, this is from before, this picture over here, that if there is a current in a wire will produce a magnetic field. A current in a wire will produce a magnetic field. Okay, so current equals magnetic field. Well, we find that the opposite is also true. A magnetic field, a magnetic field will produce a current. A magnetic field will produce a current. And I'm going to amend this statement slightly. A changing magnetic field will produce a current. So a changing magnetic field will produce a current. And that's what this picture is trying to show you. We have a coil wrapped around a bar here, just a bar to make an electromagnet. And we have a bar magnet sitting next to it. There's no motion in this picture here, so you can see that this has a zero current, has 0 amps of current going through it. But what we do is we take this bar magnet and we start moving it back and forth. We start moving it back and forth. That causes a changing magnetic field. And this changing magnetic field produces a current in the wire here, in the wire. And as you can see, when we move it one direction, the current is positive, and we move in the opposite direction is negative. So the current's going to reverse back and forth depending on the motion. And we'll get to that later about determining which way the current's going to be. So a changing magnetic field will produce a current. This is what we call an induced current. We call this an induced current. Okay? It is induced by the changing magnetic field. This is also called an induced, one too many C's there, an induced EMF. An induced EMF. Remember, EMF stands for electromotive force, and this is essentially voltage. So this is voltage. So basically, this bar magnet moving back and forth acts like a battery. This bar magnet induces a voltage. A voltage is the push, remember, and the current is the flow. The voltage pushes, electrons move. So an induced EMF causes an induced current there. Okay? So this coil starts, or this magnet, this coil starts behaving like it has an EMF, okay? And so if we took our leads here and we connected two more leads to here and we attached it to a voltmeter, we will be able to get a voltage from this. It's an induced voltage based on this bar magnet moving back and forth. Okay? So we're going to describe three situations that will induce a current. Okay? Three situations. The first situation, as you can see here, is by a changing magnetic field. A changing magnetic field. This is typically brought about by motion of the magnet. Motion of the magnet. So a changing magnetic field is caused by this magnet moving in some way. Okay, so this is the first situation. The second situation that might induce a current is if we change the area, of the wire. If we change the area of the wire. So in this one, you can see in this situation we have a constant. We have a constant magnetic field. We have a constant B. Okay? And so imagine if this wire here, imagine if this loop of wire, when unstretched, is about this big. Okay? Obviously, that has a much larger area. And that's actually not an accurate depiction there. Let me be more accurate in that drawing. Let's say the wire is about this big, normally. Well, this guy took his fingers put them in the wire and stretch them out. That changed the area inside the wire. That changed the area. So if we change the area of the loop of wire, that will induce a current as well. And third, if we change the angle. If we change the angle of the wire. So here would be the coil that we were talking about before, and if we just rotate it in relation to the magnetic field, that will also induce a current as well. So as you can see here, the general statement here is a changing magnetic field. A changing magnetic field. This magnetic field can change due to the motion of the magnet. This magnetic field can change if we change the area inside the loop of wire. By changing the area of the wire itself, or it can change by the angle of the loop of wire changing, which in essence does change the area as well. Okay, it's kind of, those two are kind of the same, but those are the three situations that's going to cause an induced current in a wire.